Okay, so we're back with another example of prime factorization. Again, before we continue, let's go over those words again. Prime. Prime number will be any of these numbers you see right here in green. And those numbers in green only have two factors. What I mean is, let's take 29 for example. 29, there's only two numbers that you multiply to give you 29. And it would be 1 and itself. So, prime numbers only have two factors, 1 and the number itself. Another example would be 41. What are the only two numbers that exist that are whole that I multiply to give me 41? Again, since it's prime numbers, it's only going to be 1 and itself. So it's got only two factors. That's what it takes to be a prime number. Anything that is not a prime number is called a composite. So all these that you see in white over here, anything that's going to be in white is known as composite. Composite numbers. But we're not looking for composite numbers here. We're looking for prime factorization. So, if a number is a composite number, it's going to receive two branches. Okay? Two branches. And what I need to do is figure out what two numbers, all right, that when I multiply, give me 84. If you ever have trouble, use your multiplication chart. So here's my chart. Let's use it for helping me start off to get 84. What you want to do is see if you find 84 anywhere here in the chart, and if you do find it, it's automatically going to give you the two factors that you can use. Are those the only two numbers? No, there's plenty of combinations for certain numbers. 84 has more than three factors. How many? I don't know, but all you need is just two of them. Here's 84. Do you guys see it anywhere else? Not that I need to find it anywhere else, but just in case. Ah, there it is. Okay, so if you follow each column, it's going to take you to the factors of that number and the rows as well. So if you multiply 12 times 7, it gives you 84. So I could use right here the factors of 12 and 7. Those are my factors. So I'm going to put right here 12 and 7. Same thing for the other numbers too. Right here is 7 times 12. So it's the same thing. So if you get 12 and multiply by 7, you end up with 84. I found it out by using a multiplication chart. If you get stuck and you can't figure out what numbers to use your multiplication chart. Are those the only combinations? No. Another one I can think of on top of my head would be 27 times 2 also give me 84. So if I had wanted to, I could have started off with these numbers instead. I could go with this, or I could go with what I had before. Either one will give me the right answer. I'm going to stick to what I had first. But I'm just letting you know that there's more than one way, more than one combination to get your final answer. All right, so let's continue. Now, we're going to look at the new numbers that we have. 12 is known as a composite number. All right, if you forget, let's go back to our chart over here. All right, and since 12 is right here in white, all right, anything in white is known as a composite number. So that means it gets two branches. 7, on the other hand, is not composite. It's in green. That makes it a prime number. if it's a prime number, it only gets one branch. Again, if it's a prime number, it gets one branch. Composite gets two branches, 1, 2. Prime gets 1. And if it's a prime number, what do you do with that one branch is you just slide that same number down. There we go. Now I got to think of what two numbers that when I multiply give me 12. Again, if you get stuck, just use your multiplication chart. But for number 12, it shouldn't be that hard. You can either use 2 times 6 or 3 times 4. Either one of these, all right, either these two numbers or these two numbers will work. I'm going to go with 3 and 4. Now, do I stop or do I continue? Here's how you can tell if your tree continues to grow or you branch out more. If any one of these numbers in this new row is a composite number, that means you must continue. And I spot one of them. Which one of these three, of 3, 4, and 7, is composite? That'll be number 4. If you go over here, 3, 4, and 7. 3 and 7 are prime numbers, so they get one branch. Okay, 4, which is here in white, gets 2 branches because it's composite. And like I did before with 7, you slide it down again. So prime numbers, all you got to do is just slide them down. So right here I'm going to put 7, and over here I'm going to put 3. So let's do that. There we go. My computer froze for a little bit. It's okay. So 7 goes here. I slide it down, and so does 3. And I'm almost done. Now I got to think of what two numbers that when I multiply give me 4. Well, there's only 2 possible numbers. 2 and 2. You can use the same number, all right, if you're making your tree. The only number that you cannot use when you're making your factor tree, you need to remember this, is 1. 1 is not allowed, okay? So don't forget that. All other numbers are okay. Now my tree stopped growing. It stopped branching out. Why did it stop? Because 3 is prime, 2 is prime, and so is 7. Once all the numbers are prime, your tree stops growing. But your work's not done yet. Now what you got to do is put them in order from small to big. So let's do that. 2 times 2 times 3 times 7. And you still got one more step to do. Now you're going to put your answer in exponential form. Again, what are exponents? Let's go over it real quick. If I have 7 to the power of 4, that does not mean 7 times 4. That's wrong. This 4 is letting me know how many times I'm going to use this number, my base, by multiplying. So I'm going to be using 7 4 times. 1, 2, 3, and 4. And I'm going to be using it by multiplying them. That's what exponents stand for. And why do we use exponents? To save space. That's what we use it for. Look how long this is compared to how long this is. So that's the main reason why we use this number, to save space. All right. So now that we went over exponents, let's go back and put the only 2 numbers that you can put in exponential form would be these 2. 2 times 2, which would be 2 to the power of 2. 2 is how many times you use your base number. I used it once, twice. So 2 to the power of 2, and the rest you bring down, times 3 times 7. And there's my answer. So the exponential form, the prime factorization of 84 is 2 to the power of 2 times 3 times 7.